Welcome to Mono Tutorials. In this session we will continue the Cyberpunk Car Timelapse series, focusing on baking and texturing. First we will look at baking considerations, then we will look at texturing. After that we will look at GLB Mirror or Duplicate Polygon Approaches, before finishing with an asset summary. Let's jump in.
The next thing to do is to take our high polygon assets and the low polygon assets with the final UVs into our baking tool such as Substance Painter. Blender can do baking as well, but I find Substance Painter has better baking results and texturing tools. Another tool that is popular for this sort of thing is Marmoset Toolbag. You may find there are some issues with the baking. A common issue is the detail in your low poly mesh in comparison to the high poly mesh. A common reason for this is the projection distance from the low poly asset to the high poly asset is too short or too far. You can get around this by adjusting the projection amount depending on the asset you're using, such as Substance Painter, Blender, or Marmoset. Another approach is to create a duplicate of your low polygon asset and push all the vertices outwards, which is different from scale, and this can be done with the Alt-S in Blender to create a cage of your low poly asset. So if you have some areas that need to project at a different distance than others, you can use a cage as a reference. The final approach is splitting the detail into different meshes. This may give you more control over how things bake, but this approach is very dependent on the specific issue, so it would be depending on the case. In my case, all I needed to do was reduce the projection distance a little bit to get most of the areas clear from the issues. The spoiler stand did have difficulty projecting correctly. Going back into Blender, I split the spoiler and stand mesher from the main mesh, but didn't move it, so the projection distance could be clean to each element asset and not shrink around the asset. This seemed to work fine. Occasionally you might need to fix the normal in the actual texture, and that is another approach, and usually this would be used in regards to polish anyway. So having all of these tools at your disposal will allow you to create kind of the end result that you're after. One tool in Substance Painter that I have found very useful is the ability to bake different meshes separately in the same bake by using mesh names. So any high poly mesh with an underscore high at the end, and any low poly mesh with an underscore low at the end will bake as separate assets, meaning that the ambient occlusion, or darkened areas, between the meshes is not considered. I didn't use this feature in this as I only had the one mesh, but it's a good one to know about. For the actual texturing process, I was just playing it by ear for the most part. I would occasionally look at the original reference to check elements that I was having difficulty with, such as lights and thrusters. I did a fair bit of exploration with different smart materials in Substance, and lucked upon some nice results. One thing I would have liked is more custom smart materials, but due to time, I decided not to. I think a key thing was adding the dirt and trying to make that look good. This is one of the key reasons why I only duplicated the side UVs, as these custom dirt and muck elements would look very repetitive at the top of the asset, but less obvious on the sides as you can't see both sides at the same time. I think a key thing to keep in mind is that it's a good idea to think through your approach to detail. Find the reason for all the elements you add. In my case, the dirt flowing from the insets was a key thing that I felt brought a lot to the end result. But also the bolts around the car, as much for style as utility, brings a bit of life and attention to areas around the car. I did have some trouble with the side lights and eventually gave up and turned them into metal bars. I wanted these to be LEDs to display blinkers or other effects, but found I couldn't get the finish that I was after, so switched to a simple metal detail. If I were to do this again or update the asset, I would perhaps make it multi-layered, but this would entail transparency, which adds some complexity and risk, at least with GLBs and Unity. So in some cases, it's very much pick your battles. It is pretty much always a case of refining and polishing your asset both during the process, but also at the end. Learning new things during the process helps improve elements in future projects as well. Towards the end, I start testing the end result in Blender to make sure that everything is looking how I want, and then again in my target platform, in this case Unity. Every platform gives slightly or even significantly different results, so make sure that you check your asset in all the possible target platforms before release. This may include cleaning up the textures such as the normal map manually in Photoshop, small updates to the high poly or low poly mesh, or updating the UVs in some cases where small overlaps or issues become apparent. A main consideration is that Blender, and most other platforms, will use a roughness texture by default, where Unity uses a smoothness texture by default. It is possible to export specific textures as needed to navigate this, or take your roughness texture into your image editing tool and invert it. Having both a smoothness and a roughness texture at hand is certainly useful. A big issue that I found was that GLBs don't work with mirrored polygons or overlapping UVs as well as FBX does. They looked fine in Blender, but once I got to Unity, there were some serious normal issues that I had to clean up. The workaround that I found for this is by importing the asset into Unity as an FBX, and then exporting it as a GLB using the GLFast package. Importing back into Blender and reapplied all of the materials, making sure that maps apart from the diffuse map are set to non-color on their image texture node. The export process from Unity seemed to reduce the quality of the textures. Therefore, I had to re-upload them to the original asset. For some reason, exporting from Unity, putting into Blender, and then re-exporting into Unity seemed to fix this issue. This and other GLB material considerations are covered in a doc linked in the description below. As always, depending on the asset, depending on your approach, depending on what you're trying to do, the issues are wide and varied, but over time you start figuring them out, to the point that you work around them before they even happen. So with that, the car itself is finished. We have a GLB hover car of 7,034 triangles with one material using diffuse map, roughness and metallic map, and normal map. The diffuse and normal maps are 2048 by 2048, and the metallic roughness map is 1024 by 1024. The total file size is less than 11 meg, which is a bit high due to the texture size, but as this would most likely be a key asset for driving or an environment, it works out. If this was more a background asset, I would definitely reduce all the textures to 1024 by 1024. We hope you've got something useful out of watching this series. It's a long process, but I feel the results are certainly worth it. The biggest lesson for me was the fact that GLBs don't support mirrored or duplicated UVs so well, but I was able to work around this and can use the same approach in future mirrored assets, which is fantastic as this utilizes texture space considerably better than not. Thanks for watching, and happy building!